Hello everyone, and welcome back all of you to another video of this NumPy course. So, today in this video, we will be looking at some very common ways of creating NumPy arrays. So, we will learn how to create NumPy arrays. Okay, then along with that, we will also look at some basic attributes of NumPy arrays like their shape, size, dimension, dtype, and astype method. Okay, then at the end of this video we will look at some ways to rearrange the data in NumPy array using methods like reshape, ravel, and flatten. Let me go into my notebook now. So here I am in my Jupyter notebook. So I will first start by importing the NumPy module. So I will say import NumPy as np. I'll run this. So we have imported our NumPy module using the alias as np. So this is a very standard way of importing NumPy. You will see it everywhere almost. Okay, now let us start by first creating our NumPy array. So I will write np.array. This is the most common method to you. This is the most common method used to create a NumPy array. So inside this function, I will pass a list, say 1, 2, 3, and I'll run this. So what we get here is basically a NumPy array. It says array and this list 1, 2, 3. Here note that you can also use tuple to create a NumPy array. For example, np.array, and inside this function I will pass a tuple, say 1, 2, 3. I'll run this. So you can see that we are getting exactly the same type of array that we get here. Okay. We can also use the range method if you know in Python. So I will write np.array, and inside this I will pass that range sequence basically. So for example, I'll say range 4. All right. So it will generate the NumPy array inside which there are these values from 0 to 3. So this is what basically the range function does, right? It generates the sequence up to the number -1, so 0 to 3, and we have passed it to np.array, so we are getting an array back. Okay, so here let's create a variable, say a1 is equal to, and to this variable I will assign a NumPy array. I will say np.array 1, 2, 3. Then I will like to print this. Okay, so we have just created a NumPy array and passed it to a variable a1. Now we will look at some basic attributes related to NumPy arrays. Okay, so let us first start by looking at what actually a1 holds. So I will write type a1. It says numpy.nd array. So this is actually the name that is given to the data structure that the NumPy provides us. So nd array we call them. When I say NumPy arrays or nd arrays, I'm actually referring to the same thing. So don't get confused. So we call these as nd array. Okay. For example, if I created a list and I write type L1, it says list. So basically this is the name of the data structure that this variable L1 holds. We know it's a list, so we get back list. Okay, so remember that the type of NumPy array we get as numpy.nd array. Okay, now another attribute that is very important to know is I will write a1.size. It says 3. So what it basically tells us is actually the number of values inside our NumPy array. So let me clear this first. So in the array a1 that we created here, we have 3 values, 1, 2, 3. So a1 dot size gives us 3. Okay. Now let us go to another very important variable, that is a1 dot shape. Now this can be a bit tricky for beginners, but let me explain you clearly. This tells us basically the number of elements across each dimension in our NumPy array. So here our NumPy array a1 is basically a one-dimensional numpy array. If I do a1 dot ndim, I can check this using this attribute called a1 dot ndim. So it gives us 1. So this array a1 is basically a one-dimensional numpy array. We call it as a 1D array. Okay. So since it has only one dimension, we are getting the number of values across this dimension, that is 3. So this is a tuple 3 comma. Wherever you see this, just understand it that this is basically a one-dimensional array which has 3 values inside it. Okay. To make it more clear, let me go into the board now. So here, what I've created just now is np dot, okay, let me change the color here. I said np dot array, and inside this I passed a list called 1 2 3, and it gave back me this numpy array. Okay, so this is basically a one-dimensional array because it has only one axis. So let me show you. This has only one axis, and let us just name this axis 0. Okay, so along this axis there are three values, 1 2 and 3. That's it. So 1D numpy arrays are really simple. So let me go back to my Jupyter notebook, and now I will introduce you to another attribute, that is a1 dot d type. This gives us the data type of the values that are there in the numpy array a1. Okay, so we know that there are integers 1 2 and 3, so we get the data type as int 32. Okay, so this basically just tells us the data type of the values inside our numpy array. If we want to change, we can also change the data type of those values using a method called a1 dot as type, and inside this just pass the type that you want to convert values to. Say I want to convert it to string, so I will do str and run this. Okay, okay, there is a typing mistake as type. Okay, so now what I get back is a numpy array. Inside this there are these strings. Basically now they are no longer integers, they are strings. I can also convert them, say boolean values, so they are now boolean values. Please note that it doesn't change the original array. Our original array even is still the same, you can see. It just gives back another transformed array with the changed data type. Okay, now till now we have just created a simple one-dimensional numpy array. Now let us try to create a 2D numpy array. Okay, so let me first show you what a 2D numpy array looks like. Let me go to the board. So here I will show you what a 2D numpy array looks like. To create a 2D numpy array, what I will do is I will write np.array, and inside this time I will give a list, but this time it won't be a simple list, it would be a nested list. Okay, so nested list means basically list inside another list. Okay, so let us create our list. This is the outer list. Okay, let me write like this. Inside this I will create two lists. Okay, this is list 1 and this is list 2. So there are two lists inside this outer list. So this is basically a 2D numpy array. Let me give values inside this. Say I am giving two values, 1 2 3 4. So this is a 2D numpy array. Okay, and how we will represent it? We can write this as a matrix. Okay, like in mathematics, you know, if we call this as a matrix, this is a 2 cross 2 matrix. So it has two rows and two columns, and values will be arranged like this: 1 2 3 4. All right, so we call this as a 2D numpy array, and let me show you that this is basically one axis and this is basically another axis. Okay, so there are two axes this time. In this we saw that there is only one axis because this is a 1D numpy array, this is a 2D numpy array because this has two axes. Let us say that this axis is axis 0. I'm just giving a name to it. And this axis, let us say this is axis 1. So axis 0 is basically related uh, to the rows. Sorry. Let me correct this. So I should say this is axis 0 and this is axis 1. Okay. So axis 0 basically relates to the rows and axis 1 basically relates to the columns. Okay. So this has two axes. So this is a 2D numpy array. Now let us try to create this in our notebook. I will write np.array, and in the same way that I showed you in my board, I will write this nested list. So 1 comma 2, another list 3 comma 4. So this time this is a 2D numpy array that we get here. Let me create a variable to store this first, then we will try to work with this. So np.array, a list. Inside this we have two lists. Okay, let me print this also. Fine. So we have a2. Let us check the dimension of this array. I will do ndim. I should be getting here 2 because I just told you that it is a 2D numpy array. So this is a 2D numpy array. All right. If I write a2 dot size, I told you before that this size attribute actually gives us the total number of values in the numpy array. So when I write size here, it gave me 3 because a1 had 3 values. Okay. Now when I write a2 dot size, we see that a2 actually has 4 values, 1, 2, 3 and 4. Okay, we have to count these values actually. So let me run this. We should be getting 4. Okay, so this has total of 4 values in a2. Fine. Okay, perfect till now. Now let us try this attribute also, which is very important, a2 dot shape. If we see the shape, so this basically tells us the number of elements across each axis or each dimension. So we have already seen that this 2D numpy array has two axes, axis 0 and axis 1. So across each axis there are okay, let me show you here. So across each axis there are two elements. So what are they? So in the first axis we have rows, basically this list and this list. So in the first axis we have two rows, we call them rows. Okay, and in the second axis we have two elements and that are two columns. So read it like this. Okay, so let me make you clear there here also. So this is a 2 cross 2 matrix. This is also the shape of this matrix. Okay, so the shape is 2 cross 2. Shape of this 1D numpy array was just 3 comma, sorry, not 1, it will just say 3 comma. So just one axis, 3 values along this axis. In this 2D numpy array we have two axes and along each axis there are two elements. What are they? So along this axis 0 we have two rows. We know this is row 1, this is row 2. Okay, and along this axis, which is axis 1, we have two elements. And what are they? Basically the columns. This is column 1 and this is column 2. So 2 cross 2 is the matrix. This is matrix 2 cross 2 and we call it as shape. So read the shape as 2 cross 2. So here it is 2 comma 2. So it's better if you read it as a 2 cross 2 because we have seen that a 2D numpy array is a lot similar to a matrix in mathematics. Fine. Now with the same logic we can also create a 3D numpy array, and for that we will create a nested list which is 3 times nested. So actually I have an example here. You can see here we have only one list, so this is a 1D numpy array. Here we have a list. Inside this we have two other lists. So list inside list. So this is basically a 2D numpy array. And what would its shape be? Its shape would be two rows, and inside these we have three values. Okay, so these three values, so 2 cross 3. If we were to make this in a matrix format, we would write 1 2 3 4 5 and 6. So this is 2 cross 3. Okay, here this is a 3D numpy array. Why? Because see here, this is a list, outer list. Inside this we have two lists. This red one, if you can see, we have two lists separated with a comma, and inside these lists as well we have two more lists, these color. Okay, you can see two more lists. Okay, inside each of these lists we have two more lists, and inside these lists we have two values for each list. Okay, so this is basically 3 times nested list, so that's why this is a 3D numpy array. All right, now we can keep creating nested and nested list to create a more high dimensional numpy array, but for this numpy course we will be mostly working with 1D numpy arrays, 2D numpy arrays, and yeah, uh, sometimes we will see 3D numpy arrays, but mostly we will be seeing 1D numpy arrays and 2D numpy arrays only. Okay, so let me create here in this Jupyter notebook. So I will write np.array. So I will create an outer list. Inside this I will create a list. Inside this list I will create another list. Fine. Okay, I will write 3 comma 4. So this is the list. So the similar type of thing I will create here, 5 comma 6, 7 comma 8, and I will run this. So this is a 3D numpy array. Let me assign this to a variable as well. Let me copy this. All right, and I will print this also. So A3 is our 3-dimensional numpy array. How can we check this? We can do A3.endIm. This is a 3D numpy array. Okay, if I do A3.size, it should give us the total number of values that this numpy array holds. We can see there are 1 2 3 4 5 6 7 8 values. All right, fine, it gives us 8. Now if I do A3.shape, it tells me the total number of elements across each dimension. So this is 2 cross 2 cross 2 numpy array, basically a 3D numpy array. Now to visualize this, let me go to the board. Now let me create this 3D numpy array. Okay, let me see what the data was. Okay, 1 2 3 4 5 6 7 8. Fine. So let me go to the board now. I will try to create a 3D numpy array. So I will write np.array. Inside this I actually have two arrays, 1 2 3 4. Fine. Okay, 5 6 and 7 8. So you can see there is list inside a list, which is inside another list. So 3 times nesting. So that's why this is a 3D numpy array. Now how it looks like, something like this. You can visualize 3D numpy arrays like this structure. Okay, so wait, so I will just draw it fully. So this is what a 3D numpy array looks like. It should have 3 axes because this is a 3D numpy array. So let us write down the axis. So this is first axis, this is the second axis, and this will be the third axis. Let me write their names. So we will call it as axis 0. This is the axis 0, and this is axis 1, and this is axis 2. So there are a total of 3 axes: axis 0, axis 1, and axis 2. So let me tell you what they actually relate to. Okay, axis 2. So axis 0 basically relates to the matrix that we will try to select. There are two matrix, you can see. This is a matrix, behind this we have another matrix. So axis 0 actually relates to the matrix. So we will write down the shape as 2. So 2 because in the axis 0 we have 2 matrix. In the axis 1 we have 2 rows, that is we will write like this. So in the axis 1 we have 2 rows, so that's why we'll write 2. Then in the axis 2 we have 2 columns basically, so column 1 and column 2, so 2. Fine. And the same thing we can do for the axis, the matrix that is behind. We will write 5, 6 and 7, 8. Okay, so it has shape 2 comma 2 comma 2. Why? Because axis 0 has 2 matrix, axis 1 has 2 rows, axis 2 has 2 columns. Okay, it need not be necessary that the shapes that the elements in each dimension is same. It's just a coincidence here. Okay, so that's why this is a 3D NumPy array. All right, it has 3 axes. So now let us see some more common ways of creating NumPy array. Till now you see that we just use this dot array function, and inside this we just passed these list to create NumPy array. Okay, now the first method that can be used to create a NumPy array is np.arrange. Now this works a lot similar like a range function if you know in Python. So let us see first what a range function does. So I write range to say 8 and 2. Sorry, I will have to, okay, I will have to write this list. Fine. So what it does is it creates a range sequence for you where you give the start value, stop value and the step value. Here we can see that it starts from 2 and with a step size of 2 it keeps incrementing. Now this 8 is exclusive, we know that, so it will just be till 6, so 2, 4 and 6. So we can just write the same way in this dot arrange method. So say for example I'll write 2 comma 10 comma 3 and I will run this. So we get a NumPy array which starts with 2 and ends before 10 and the step size is 3. Okay, so here in the first, if we see that we use this range method inside this dot array method, so in this we don't have to use this, we can simply directly use this dot arrange and use it like a simple range function. Fine. Now there is another method very similar like a range arrange method, but here what we provide is, let me write np dot line space. Inside this sorry, not list, inside this I will provide a start value. Say for example I want to start from 2 and I will provide a stop value. So okay, let me provide 1 and I will provide a stop value that is say 10, and between 1 and 10 I will provide the total number of values that I want. Okay, so that makes sense, right? What happened in arrange, what we provided is we provided the start value, the stop value and the step value. So we didn't know the total number of values that we will get, we just provided the start, stop and step values. What we provide here is we provide a start value, we provide a stop value and we provide the total number of values that we want in between 1 and 10, and 1 and 10 are also both included. So for example, let's say I want 5 values. So here NumPy will automatically calculate the step size. So if you see closely, then between all the values, between all the consecutive values, the difference is same. So it's, I think it is 2.25. Yeah, you can see. So each of the element is separated by a value 2.25. So from 1 to 10 we have 5 values in total. Okay, so this is this has a size of 5. All right, so this is also a very common way of creating NumPy arrays. Now there are also few more ways of creating NumPy arrays which are used a lot in things like linear algebra and stuff. So okay, so let me write first np dot zeros. So what it does is we will have to give it the shape that we want to create. For example, I want to create a 2D numpy array, and I will give the shape, say 4 comma 3. So 4 rows and 3 columns. That's the matrix that I want to create, and it will create that matrix. See that it fills that matrix with all the 0 values. Okay, so np.0, and inside this you give the shape. It creates a matrix of that shape with all the 0 values. So this is also very useful when you want to like initialize a numpy array. Okay, we can also write np.once. I think from the name it should be very clear what it will do. So let's see, for example, if I pass 5 comma 1, make sure that you pass it in a tuple. Okay, 5 comma 1, sorry, okay, 5 comma 1. So it will give me the numpy array, which is 5 cross 1, so 5 rows and only 1 column, and it will fill that matrix with all the 1 values. Now suppose we want to create numpy arrays in this way, but what we want is not zeros and ones, but we want some other number that should be filled. So that is also available in numpy, and we can do this using np.full and pass on the shape first. Say I want a 3 cross 4 matrix, and what is the value that I want to fill it? I will just give, say I want to fill it with 3.14. So it gives me a matrix, sorry, a numpy array, which is a 2D numpy array, and it has 3 rows, 4 columns, and it is filled with 3.14. Okay, I can also create a 3D numpy array. Okay, like this. So for 3D numpy array, I will have to specify the number of elements in 3 dimensions, right? So I will say, for example, 2 cross 3 cross 2, and I want to fill it with, say, 2. So this is a numpy array, this is a 3D numpy array. It has 2 matrix. Okay, so this is first matrix, this is second matrix. Inside each of these 2 matrix we have 3 rows. So because we provided 3 here in the second axis, so we have 3 rows, and then we provided 2 in the last axis, which is the columns. So each of these matrix has 3 rows and 2 columns. Okay, so you will have to read it like 2 cross 3 cross 2. Fine. Now I will just explain you what we discussed in code. np.arrange, what we have to give it here is, say, np.arrange. So it accepts 3 inputs: start value, stop value, and the step value. So this is the start value, this is the stop value, and this is the step value. So for example, if I write np.arrange, just say start with 4 and stop at, say, 11, and the step size 2. So what it will give me? It will give me a numpy array. It's a 1D numpy array which starts from 4 with a step size of 2. So 4 plus 2 6 plus 2 8 plus 2 10 plus 2 12, but 12 will not be included because it exceeds 11. So we will just stop here. So this is a numpy array. It's a one-dimensional numpy array which has shape 4 comma. Okay, that's it. Then we saw this np.linespace. np.linespace, what it does was, we have to provide it three arguments, say start value, stop value, and here we provided the number of values that we want in total. Okay, so for example, np.linespace, say 3 to 3 to 7. I want values from 3 to 7, and in total, say I want just say 4 values. So I will have to actually run this code, what it will give me. So let us see here, np.linespace 3 and 7 and 4. So these are the values that I'm getting. Okay, so I'm not just writing on this board, you can just see here, these are the values that I get. So starting from 3, stops at 7, exactly starts from 3, exactly stops at 7, and there are 4 values that you get in total, which are equally separated from each other. That is the main point that you should remember. Okay, then we saw these other methods like np.zeros, ones, and fulls. So what np.zeros does is np.zeros, for example 2 comma 3, it will give me 0 filled matrix which has 2 rows and 3 columns, so 0 0 0. So this is 2 cross 3 matrix. Okay, sorry, so it has 2 cross 3 matrix. And np.ones, you can skip this if you already know all this. We just executed in the code as well. So I'm just writing here for the notes, say for example 3 cross 1. So it will be 3 rows and just 1 column, and all will be filled with ones. And then we saw np.full, where we provide a shape and the fill value. So not just zeros and one, we can create a matrix of any desired values that we want inside. So for example, np.full, I provide the shape as say 1 comma 3. So you have to pass the shape as a tuple. Then you will have to provide a fill value. For example, I wanted to fill with 3.14. So I should be getting an output which is a matrix of 1 rows and 3 columns. Okay, so this is not a one-dimensional matrix, sorry, not a one-dimensional numpy array. This is a 2D numpy array because this has 1 rows and 3 columns. Okay, you have to read it like this. Fine. So I will fill the values 3.14, 3.14. Fine. So let us come to the last part of this video, that is reshaping ND arrays. So reshaping numpy arrays basically means rearranging the data in numpy array. Okay, rearranging the data in numpy array. So we will look at few methods of doing this. For example, using dot reshape method. So first look at this example. So for example, I have a numpy array which has values from 1 to 6, 3, 4, 5, 6, and I would like to convert. So first this is a 1D numpy array, okay, which has shape 6 comma, sorry, 6 comma, okay. So say for example, I would like to convert this numpy array into a 2D numpy array. So I will convert this into a 2D numpy array which has shape for, let's say, 3 cross 2. 3 cross 2 means it will have 3 rows and 2 columns. So let us start by filling the values in this numpy array to this numpy array. So I will start from here and I see 1, 2. So I will write 1, 2. Then we have 3, 4, 3, 4. Then 5, 6, 5, 6. So if you observe closely, what I have done here is I actually filled this numpy array, which is a 2D numpy array, by rows. So I fill first row with 1, 2, then I move to the second row, then I write 3, 4, then I move to the last row and I write 5, 6. So this way I have reshaped this numpy array, which was one dimensional, into a 2D numpy array which has shape 3 comma 2. You can reshape this array into any shape you want. Just see that the total elements, sorry, the total values that this array can hold should be same. So I cannot convert this specific one-dimensional numpy array into a 2D numpy array which has shape 5 cross 2 because of 5 cross 2 matrix. 5 cross 2 matrix will have 5 rows, 2 columns, and it will have 10 values. Okay, it should have 10 values, but my 1D numpy array only has 6 values, so it can only be converted to appropriate shapes. So you can convert in 3 cross 2, you can also convert it into a 2 cross 3 numpy array. So let us do this in code, what we have done here on the board. So first I will create, say, a4 is equals to np dot, I will use this arrange method, and I want values from 1 to 6. So I will write 1 comma 7, and yeah, I would like to print this. So we have created a one-dimensional NumPy array from 1 to 6. We have values. Now I will I will transform this NumPy array into a 2D NumPy array using dot reshape. Okay, spelling. Okay, dot reshape, and I will provide here the shape that I want to convert into, say 3 comma 2. So we get a 3 cross 2 NumPy array which has values taken from this 1D NumPy array. Okay, so also note that this original array is not changed, it is still the same. We are just getting a view of this transformed array. So I can also write a4 dot reshape, and this time say I will write 2 comma 3. So this is also valid because a 2 cross 3 NumPy array will also hold 6 values. If I write say a4 dot reshape say 7 comma 4, it will give me an error because it says it cannot reshape the array of size 6. So this A4 has size 6 because it has 6 values into a shape that is 7 comma 4. Why? Because 7 comma 4 will hold 28 values, and our array A4 has 6 values, so it will give this error. Fine, I think this is a lot clear now. Now there is something like order that I would like to explain. In this dot reshape method, don't you think that this 1D NumPy array I could also convert into this 3 cross 2, but this time what I will do different is I will first fill the columns. Okay, so first let me erase this. Okay, fine. What I will do this time, I will first fill the rows. So I will fill this, first fill the columns. So there are two columns. So I will fill the first column. So I will fill it by the values 1, 2, 3. So 1, 2, 3. Then I will fill the second column by the remaining values, that is 4, 5, 6. So 4, 5, 6. Okay. So these are both 3 cross 2 NumPy arrays, which are 2D NumPy arrays created from this same 1D NumPy array. But the way the way the values are arranged is different. You can see here. So in this, I actually filled the values by rows. So I filled first 1, 2, then 3, 4, then 5, 6. So by rows. And here what I did, I filled first this first column using the 3 values, then the second column. Okay, so by column. So what's the difference? Let me write it. What's the key difference? Here I filled by rows, by columns, and here I filled by rows. So that's the main difference, and we can achieve this basically using an argument called order. So I will write here a4 dot reshape, and this time also I will convert it to 3 cross 2, but I will say order is equals to capital F. So this is a string. So if you write capital F, order is equals to capital F, this has reshaped into a 3 cross 2, but this time you can see that it has filled the values by columns. So in the first column we have filled the values 1, 2, 3, and the second column 4, 5, 6. If I write order is equals to C, it will do that default thing that we saw here. Okay, so by default you are pretty clear now that by default the order is C. But if we want to fill the matrix by this second method by columns, then we will have to pass order as F. Okay, here the order would be C, and we don't have to write this because this is the default order. Okay, so these are the two ways. I've just taken an image to illustrate this example using a NumPy array, which is, so this is a 1D NumPy array. Okay, which has shape as 12 comma, because it has 12 values in this axis, it has only one axis, it has 12 values. Okay, so if I want to convert this 1D NumPy array into a 2D NumPy array, I have two ways. I explained in the previous slide that order is equals to C and order is equals to F. So order is equals to C is the default one, that is filled by rows. So first 0, 1, 2 come in the first rows, then 3, 4, 5 in the second row, then 6, 7, 8 in this row, and then 9, 10, 11 in the last row. So filling by rows. And in the second method, you know that it is by columns. So the first column 0, 1, 2, 3, then second column, then third column. So by columns. And we can do it by passing order is equals to F, and by rows order is equals to C. So these are the two very common ways of reshaping arrays. Now there is also something called as dot revel. What it does is it is just the opposite of dot reshape. So for example, I have a numpy array which is a matrix actually, which is a 3 cross 2 matrix, and this is a 2D numpy array. So I would like to convert this to a 1D numpy array. Okay, 1D numpy array which has shape 6 comma, and say so let's start by filling in the values 1, 2, 3, 4, 5, 6. Okay, let us try to do this in code. So I will first create a numpy array using this arrange method, and I want values from 1 to 7. I will use dot reshape 3 comma 2, and I would like to show this numpy array to you. So this is a numpy array, 3 rows 2 columns. Now I would like to basically rearrange the data, but this time this is a 2D numpy array and I would like to convert it to a 1D numpy array. So I would write dot revel. So this is converted to a 1D numpy array. Okay, now the same thing that we saw in previous slide, that order is equals to C and order is equals to F by rows and by columns. So same logic you can apply here as well, that here first I filled the values by rows. So 1, 2, 3, 1, 2, 3, then the next row 4, 5, 6, 4, 5, 6. So here I have filled by rows, okay. Another way of doing it is by using by columns, okay. Let me write this by columns. So I would want to change this to 6 comma as a one dimensional array, but this time by columns. So I would start filling by column first. So first this first column, that is 1, 4, then the second column 2, 5, then the last column 3, 6. So both of them are 1D numpy array created from this 2D numpy array, but the difference is how they are arranged in this different ways. So here also we have this order. We can use order is equals to F to do arrangement by columns, and order is equals to C is by default for rows. Okay, let us do this in code. So I would say a5 dot revel, and this time I would pass order is equals to F. So you can see this was 1, 2, 3, 4, 5, 6. This is 1, 3, 5, 2, 4, 6. So by columns. Okay, you can open it by columns. It would look something like this. Okay, now there is also another method called dot flatten. It also works the same way as dot revel. Whatever we have seen in dot revel, but here there is like a small difference, that is it returns us a copy of the numpy array. So I will be explaining this in further videos. For now, just remember that it works the same way as dot revel, but it returns us the copy of the numpy array. So I can show you this. Okay, for example a5, and I will write a5 dot flatten. It does the same thing as dot revel, and I can also write a5 dot flatten, and I will write order is equals to F. So yeah, we are getting it by columns. Fine. So I think we have made it to the end of this video. Yeah, so we have seen it works the same as revel. Let me write it. Works dot revel. Okay, So there is only one difference, that it returns the copy of the numpy array. Okay, so we have made it to the end of this video. I hope you really enjoyed learning all these things that you saw today. So yeah, see you in the next video of this course. Till then, keep learning.